All right, in this video, we are going to work another example of a linear inequality that has fractions in it. Okay. All right. So, taking a look, since this equation has fractions in it, one of the things that we are going to do is to find the least common denominator of all the fractions, and then multiply both sides of the inequality by the LCD, and that will remove the fractions for us. So just looking at the denominators of these fractions, I have a 3, a 4, a 2, and a 6. A 6 is the largest of those numbers, and 2 and 3 both go into 6, but 4 does not. And obviously 6 goes into itself. But since 4 doesn't go into 6, then the next number that we'll look at is 12. That's 6 times 2. And you can see that 3, 4, and 2 all go, and 6 all go into 12. So 12 is going to be the smallest number that 3, 4, 2, and 6 all go into evenly. So that's going to be our LCD. Okay, so once we have the LCD, then we are going to multiply both sides of the inequality by 12. Whenever you multiply both sides of an inequality by a number, right, you need to stop and check and make sure that it is positive, right? And so, because if it were negative, then we would have to flip the inequality sign. But since we're multiplying both sides by a positive number, we do not have to change the direction of the inequality sign. So we're going to multiply both sides by 12. Okay, and I put both sides in parentheses, which I just drew as brackets, just a little bit easier to look at when you have nested parentheses in there. But functionally, for us, they're the same as parentheses. And the reason I did that is because each side has more than one term. You have two terms over here and two terms over here. So I did not forget to distribute that 12 to both terms inside on either side. Okay, so I'm going to take that 12 and multiply it times the 2/3 x plus 7, and I'm going to take that 12, right, and distribute it to the x over 4, and the same thing is going to happen over on the other side. All right, so I'm going to distribute that 12 to each of these terms. All right, and then remember, if we do this correctly, then all of the fractions should cancel out. Okay, so first over here, I have 12 times 2/3, right? So I can think of that as 12 over 1 times 2/3 if I want. And I do have a common factor of 3. 3 goes into itself once. It goes into 12 4 times. So I'll have 4 times 2 on top, which is an 8. And on the bottom, I will have 1 times 1, so 8 over 1, which I'm just going to write as 8. All right, next up, I have this 12 times x over 4. Again, 4 goes into 12 evenly, right? 4 goes into itself 1 time, and it goes into 12 3 times. All right, so that's going to be 3 times x. Here, 12 times a half would be 6. And for this term, 6 goes into itself 1 time and goes into 12 2 times. So I would wind up with 2x over here. So the LCD did its job. Our multiplying both sides by the LCD did its job, right? And now we have an inequality without fractions, which is a little bit easier to deal with. Okay, so next up, just keep simplifying both sides as much as possible. So over on the left side, I am going to distribute the 8 through the parentheses and get 8x plus 56. And just rewrite the minus 3x. Over on the right hand side, I am going to distribute the 6 through the parentheses and get 18 minus 6x. And don't forget to bring down that 2x. So each side is a little simpler than it was. I still have some simplifying to do because I have some like terms here, this 8x and the minus 3x. So 8x minus 3x will be positive 5x. Over on the right-hand side, I have some like terms, the minus 6x and the 2x. So those can be combined. And that will be minus 4x. So at this point, I have all of each side as simple as I can get it, right? There's no more combining I can do here. So the next step would be to use the addition property, right? And my goal would be to get every term with an x on one side, every term without the x on the other side. So there's multiple ways in which you can do that. So just one way to do it would be to add 4x to both sides. And when I do that, I get 9x plus 56 is greater than 18. Okay. All right, and so now you can see I have every term with an x over on the left side, every term without the x, not yet over on the right-hand side. There's still one thing I have to do and move this 56 over by subtracting 56 from both sides. All right, and when I do that, I get 9x is greater than, and let's see, 18 minus 56 will be, is that negative 38? Oops. I think that's right. 8 and 8, 16, yeah, 50. Yeah, that was correct. Okay, and so now I have every term with an x on one side, every term without the x on the other side. And so then I can finally use the multiplication principle. I'm going to divide both sides by 9. And so I get x is greater than negative 38 ninths. All right, and so I've got x by itself on one side, which is what I wanted to do. And I need to make sure that to see if this is reduced. But it definitely is, right? 9 is 3 times 3, but 3 doesn't go into 38 or negative 38 evenly, so that's reduced. All right, so this is our solution. The next thing that we want to do is to graph that solution out. So we would draw a number line and find negative 38 ninths, and just put that on there, the number line. And then decide whether or not the negative 38 will have an open dot or a filled dot. And because there's no or equal to here, right, if I plug negative 38 ninths in for x, I would get negative 38 ninths is greater than negative 38 ninths, which is false, right? And so that means that negative 38 ninths is not a solution to this inequality. So therefore, I would represent that with an open dot. And then I want to shade on the correct side here. The x is greater than negative 38 ninths. So that would mean that the solutions, right, would all be on this side of the number line. Okay. So that's what the graph would look like. And now that I have the graph, it's pretty easy to write the answer in interval notation. Because I have an open dot in interval notation, that would be represented by a parenthesis, and then the solutions keep going infinitely far to the right, right? So there is no upper bound on the solutions. So in interval notation, that is represented with an infinity, and of course the infinity always gets an open parenthesis in the interval notation. So that would be the solution set in the interval notation. All right. And that is it on this example.